Okay. I just leave it like that, and then once I'm actually done, because they'll be working most of the time, so once I
That
actually
would
do
be
the
another
instruction.
good reason not to have them come on.
Yeah, I didn't think about that.
Ain't nobody here today.
Okay, everybody sit down so I can do roll call, please. Yeah, everybody.
Do you want to say anything prior to starting? Okay.
Oh, I got nothing.
Okay. All right, so today we're going to be talking about some theorems that have to do with isosceles and equilateral triangles. So to start us off, we're just going to do a little refresher about what these two triangles are. So can somebody remind me what an equilateral triangle is?
Where all the sides are equal.
Yeah. So what Kate said, he said that all these sides are equal. So I know if all the sides are equal of a triangle, then that's an equilateral triangle. All right? So how about isosceles?
This way, two sides are equal.
Yeah, two sides and also two angles. Good job. So if it has either two sides that are equal or two angles, and it's a triangle, it's called an isosceles triangle. So I'm going to show on the screen different triangles, and I want you guys just to call out what you think it is. So what do you guys think this first one is? Okay, equilateral. So we know these tick marks just tell me all three of these sides are the same. So all three sides are the same, so it's equilateral. What about this one? Yeah, isosceles. So we have the two equal sides like Kate said, and the two equal angles like Carter said. So good job. Okay, this one? Equilateral. Yep, because they're all 20 meters, so all sides are equal, so equilateral. How about this? Yeah, it's equilateral. If I count these pole balls up, it's 5 here, and 5 there. So all sides are 5 long. So that's going to be equilateral. What about this?
Isosceles.
Yeah, isosceles, because it got two sides equal to 1. This one? Yeah, isosceles. Because if I look at these two tops of the coat hanger, those two sides are the same. So it's isosceles. What this one? Yeah, isosceles, two equal sides. This one?
Equilateral.
Yeah, equilateral. What about this?
Neither.
Yeah, neither. So good job. Yeah. So none of those sides are equal. So that's what we call a scaling. So good job, guys. All right. So we're going to start looking at 7.2. So if we can turn to page 327. Okay. If you guys saw those guided notes, that packet I gave you, I think some of the vocab in that packet covers these, so we're going to talk about these real quick. So like you guys already said, we know an isosceles triangle is a triangle with at least two congruent sides. So those two tick marks tell me those two sides are equal, so that's a isosceles. Okay, so we call those congruent sides, we call that the legs of the triangle. So the two equal sides are the legs. The angle formed by the two legs, so this angle right here, that's what we call the vertex angle of that isosceles triangle. So the side that's opposite that angle, so if I'm looking at the vertex angle here, the side across from that would be down here. We call that the base. then the angles that have the base as a side, so these two angles right here, those are called base angles. So those are just all the parts of the isosceles triangle. Okay. So with all that, we get the isosceles triangle theorem. So this tells us if the two sides of an isosceles triangle are congruent, then the two angles opposite those sides are congruent. So if I have a triangle ABC, sides AB and AC are congruent. This is an isosceles. So this theorem tells me that the two angles opposite those sides are congruent. So if I'm looking at side AB, the opposite angle is angle C. If I'm looking at side AC, the opposite angle is B. So all this tells me is that angle B is congruent to angle C. So if you know you have two equal sides, those angles across from each other will be equal. Okay, so let's look at a problem using this. So we're going to look at example 3, part B on page 331. Okay, so we're trying to find the measure of angle T, which is this angle here. Okay, so to find that, first we've got to figure out what x is. So since I know this is an isosceles because I have these two marks, so it tells me those two sides are equal. So with that, I can say that the measure of angle R is equal to the measure of angle S. I know that because these two sides are equal, so those opposite angles, so from here to here and from here to here, I know that these two are equal. So in that first box, I'm going to put the isosceles triangle theorem. Okay, so now I just want to substitute everything in. So I know that because the triangle sum theorem, we talked about that yesterday, we can add all the angles together in that triangle, and I'm going to get 180 degrees. So now I'm subbing in what each one equals, so I know measure of angle R equals x. Since R and S are the same, I know S also equals x. And if I'm looking at that diagram, I know angle T is 3x. So I'll put all those together, so I'll get 5x equals 180. Okay, so now I just divide by 5 to find my x, and I will get 36. I did that just by division. Okay, so now that I have my x, I just plug that in to my angle t, which angle t is 3x. So I just do 3 times 36. That'll give me 108 degrees. Okay, so the thing you want to recognize for this problem, first, once you see that it's an isosceles, you know you're going to be using this theorem. And that theorem just tells you if you have two congruent sides, those angles across from them, the opposite angles, are also equal. Alright, so let's try another one. Now, so let's look at third term problem number 5 on page 332. We'll work on that together. Okay, so since I know this is an isosceles triangle, which two angles do I know are equal to each other? Say it again.
R and P.
R and P. One more time. Yeah, Q and P. Okay, because my two congruent sides are P and R, so if I look across from P and R, that angle's Q. And if I look across from Q and R, that angle's P. So I know those two angles are equal. So I know since Q equals 3x plus 3, that means P is going to equal the same thing, 3x plus 3. Okay? Since I know the expression for that now I just need to figure out what x is. So what do I know about all three of these angles if I add them up?
180.
Yeah, I get 180 degrees. So let's do that. Let's add all three angles. So I have angle Q, which is 3x plus 3, plus angle P, which is 3x plus 3. And then I'm going to add angle R, which is 5x minus 2. And like we said, those are all angles of a triangle. So if we add them, we're going to get 180. So now what we want to do is want to simplify this. So I'm going to combine my x's, so 3x plus 5x gives me 11x. Then 3 plus 3 is 6, minus 2 gives me 4. So I'll have 176. Or sorry, not 176, I did a step ahead. Equals 180. Okay, so now I'm subtracting 4 on both sides. So I'll get 11x equals 176. Divide by 11 because I want to solve for x, so I'll get x equals 16. Okay, so now that I have that x, what do I want to do with that? Yeah, plug it in. So I'm just going to plug in for that x there. So it'll give me 3 times 16 plus 3. 3 times 16 is 48 plus 3. So that'll give me 51. So that tells me that angle P is 51. So since I know angle P is 51, what other angle is 51? Yeah, angle Q. Yeah. Okay, so is there any questions how we find those? Is everybody good? Okay. All right, so now let's look at equilateral. So on the top of page 330. Okay, so these are two more vocab words that are on that note packet. You have equilateral. So like you guys said, those are just triangles with 3 congruent sides. So if I'm looking at this, each one of these marks tell me those sides are equal, and they all 3 have them, so that's an equilateral triangle. So this other triangle is called the Equiangular Triangle. So it's like an equilateral, except it's where the 3 angles are congruent. So if I have angle A, angle B, and angle C, and they're all the same, then it's an equiangular. And then those two things can give me this theorem, the equilateral triangle theorem. So this tells me that these two triangles are the same. So if a triangle is equilateral, then it's also going to be equiangular. So if all 3 sides are the same, that also means that triangle has to have 3 angles that are also the same. Okay, any questions on that? That one's pretty straightforward. Okay, so let's look at the problem for this one now. So we're going to do, let's do example 3, part A, which is on page 331. So I'll walk you through this. So we just want to find the length of each side. So since this is an equilateral, I know that this side has to be equal to that side. So all I do is I set those equal to each other. So 6x minus 5, that's side AC. Since I know AC is the same as BC, I can set those equal. And I just want to solve for x. So I'm subtracting 4x on both sides. So it'll give me 2x minus 5 equals 7. Add that 5 over, so 2x equals 12. And then I'm dividing by 2 on both sides. So I'll get x equals 6. Okay, so now that I have that 6, all I have to do is I plug it in just like the isosceles one. I plug it in to whatever side I need. So let's plug it in there. So 4x plus 7, substituting that 6 in. So 4 times 6 plus 7. 4 times 6 gives me 24. Then I add that 7. So 24 plus 7 gives me 31. Okay, so for all these equilateral ones, whenever you see an equilateral triangle, all you have to do is just set those 2 sides equal to each other, solve for that variable, and then plug that variable back in. And that'll give you the length of those sides. Okay? So let's try just one more, and then we'll get started with our next activity. So let's look at number 8. And that's on page 335. It's one of the homework problems. So I'm going to give you guys a minute to try doing that one on your own, and then we'll talk about it. So number 8 on page 335.
So now the all three will be the same. Just leave it like that. So since we know these three, what can I do?
Okay. I think most of you guys are finishing up, so let's go ahead and talk about this. All right, so since this is an equilateral, what do I know about those two sides that's giving me? Yeah, they're the same. So that means all you have to do is set them equal to each other. So 3x minus 4 equals 5x minus 12. Okay, I'm going to move that 3x over, so I'm going to get negative 4 equals 2x minus 12. Add 12 to both sides, so that'll give me a equals 2x. And I'm dividing by 2 on both sides, so it'll give me x is equal to 4. Okay, now that I found my x, what do I want to do with that? Yeah, plug it in. So I'm just going to go ahead and plug it into the 5x minus 12. So 5 times 4 is 20, minus 12, and that'll give me 8. So I know that each one of those sides are going to have a length of 8. Okay, so these are pretty straightforward, so I think you guys are doing pretty good with them. So is there any questions on any of that, any of the isosceles or equilateral stuff? Okay. So what we're going to do now, we're going to do, when we did that little activity last week, when you guys worked on that practice worksheet, did that quiz, we're going to do the same thing with these. I'm going to pass that to you. So I'll give you guys around 30 to 40 minutes to work on that, and then we'll try the quiz.